Now, this session we are going to start with the module 5, which consists of material science. We see the classical free electron theory, assumptions and failures. Free electron concept. What exactly is a free electron concepts? We know that all metal atoms consist of valence electrons. These valence electrons are responsible for the electrical conduction in the bulk material state of a metal. Now before we start, we need to go with few definitions. Mean free path denoted by lambda. It is the average distance travelled by the conduction electrons between two successive collisions with the lattice ions, which says that in the presence of electric field, the electrons move themselves and collide with the lattice ions. That leads to the collision. So the distance travelled by the electron in the presence of electric field between two successive collisions is called as a mean free path. Similarly, mean collision time denoted by tau, which is nothing but the average distance or the average time taken between two successive collision of an electron with the lattice point is called as a mean collision time. It is the average time between two successive collisions in the presence of electric field by the electron is called as a mean collision time. Next is the drift velocity. It is a net displacement in the position of electron per unit time in the presence of electric field known as drift velocity. It is also explained as the velocity of the electron in the presence of electric field. It is denoted by Vd. Vd is nothing but E by m into tau, where E is the charge of electron, capital E is the electric field, m is the mass of electron, and tau is the mean collision time. So this is the mean free path. Lambda is the distance, mean collision time is tau, and drift velocity is Vt. Next we see the assumptions given by Drude and Lorentz in 1900 for the classical free electron theory. He says that because of the free electrons in the metal which are confined to its body constitutes an electric current. In the presence of electric field, these electrons acquire a drift velocity in a direction opposite to that of an electric field. So this is the first assumption. That means the electrical conductivity is happening because of the valence electrons and the drift velocity which was acquired due to the presence of electric field by an electron. Next point is these free electrons in the absence of electric field are treated as a gas molecules. We know that in a gas molecules atoms move randomly. Similarly, the free electrons also move randomly in the absence of electric field and obeys the kinetic theory of gas equation. Half mv square is equal to 3 by 2 kT. Here Vth is the thermal velocity of the electron, m is the mass of electron, k is the Boltzmann constant, and T is the temperature in Kelvin. So the free electron is obeying the kinetic theory of gas equation. Next is the electric potential due to ionic cores is taken to be uniform throughout the metal. That means for any metal or for any atom there exists an electric potential due to the ionic cores and it is considered as uniform throughout the metal. The attraction between the free electrons and the lattice ions due to oppositely charged particles, and that is an attraction, and the repulsion between two electrons themselves are considered insignificant. That means attractive forces and the repulsive forces between the electrons and the lattice ions are being ignored by these assumptions. Next is the relaxation time tau r. The time required for the average velocity of a conduction electrons to the exponential decay to 1 by e times its original value when the electric field is turned off is called as a relaxation time. What it says is, when the velocity acquired by an electron in the presence of electric field, the moment the electric field is switched off, it doesn't come immediately to 0. It will go exponentially. So what is the time required for the average velocity of the conduction electron to exponentially decay to 1 by e times its original value when the field is turned off? That time is called as a relaxation time tau r. Next is a current density. It is nothing but the ratio of current to the area of cross section. It is nothing but a current density. J is equal to I by A. It is given as it is a current I per unit area of cross section A of an imaginary plane held normal to the direction of the current in the current carrying conductor. What it says is J is equal to I by A. In the previous classes, we have seen that I is equal to NaEVd. So J is equal to I by A, substitute value of I. So you will be getting J is equal to NeVd. Next is electric field. The potential drop V per unit length of a conductor L gives the electric field. That means here electric field is denoted by E, which is nothing but the potential drop developed per unit length of a conductor, which is E is equal to V by L. V is the potential drop, L is the length of the conductor. Next is a conductivity. It is denoted by sigma. We all know that sigma is equal to 1 by rho, where rho is the resistivity. That means resistivity and conductivity are inversely proportional. We also know that rho is equal to RA by L. R is the resistance, A is the area of cross section, L is the length of a conductor. So sigma is equal to 1 by rho, which gives L by RA. That is nothing but a conductivity. Now electrical conductivity in metals, it is denoted by sigma, and from Ohm's law we know that J is equal to sigma into E. E is the electric field and J is the current density. We know that J is equal to NeVd and capital E is equal to, from the drift velocity equation, Vd is equal to Ee by m into tau. Substituting that value, you are getting sigma is equal to Ne square tau by m. Next is the mobility of electrons. It is denoted by mu. It is defined as a ratio of drift velocity to the electric field. So mu is equal to Vd by E, or mu is equal to sigma by Ne. Next we see the failures. There are failures in the classical free electron theory which could not explain properly. What are those? We are going to see now. This CFET could not explain specific heat, because specific heat theoretically explained by Lorentz and Root was Cv is equal to 3 by 2 R, which is approximately Cv is equal to 1.5 R. That is, Cv is equal to 3 by 2 means it is 1.5 R. But experimental value of specific heat was found to be Cv is equal to 10 to the power of minus 4 RT. If you look at these two equations, theoretically it is 3 by 2 R, but experimentally it is 10 to the power of minus 4 RT. There is a lot of difference in the values of experimental and theoretical value, and if you look at the experimental value, Cv is dependent on, that is, specific heat is dependent on temperature, but theoretically it could not be explained. And the value of value experimentally what we have got is very much less compared to the theoretical value. So experimental values are not in agreement with the theoretical value. So theory could not be explained the specific heat. So this was the first failure. Next is the temperature dependence of electrical conductivity. It was experimentally observed that for metals, electrical conductivity is inversely proportional to the temperature. You can see in this expression, conductivity experimentally is inversely proportional to the temperature. It was experimentally given. But theoretically it was different, which is given by theoretical value of sigma is proportional to 1 by root 2. There is a difference of root for a temperature. So we'll see how it has happened. According to main assumption of classical free electron theory, we have seen that the free electron is moving like a gas molecule and obeys the kinetic theory of gas equation. 3 by 2 kT is equal to half m Vth square. From here, rearranging the terms for Vth is equal to root of 3 kT by m, or Vth is proportional to root t. How we have taken here this is proportional means, look at the expression here, Vth is equal to root of 3 kT by m. T is in the numerator and Vth is also in the numerator. 3 is constant, K is constant, M is constant. Therefore, we can say that Vth is proportional to root T. The mean collision time is proportional to the thermal velocity. We know that mean collision time and the velocity are inversely proportional. Tau is directly proportional to 1 by Vth, or tau is proportional to 1 by root T. From the above equation, we say that Vth is nothing but root T, but tau is directly proportional to 1 by Vth, so therefore tau is proportional to 1 by root T. But we know that electrical conductivity is sigma, which is given by sigma is equal to Ne square tau by m. From here you can say that sigma and tau are directly proportional from this equation, but we know that tau is inversely proportional to root T. Therefore, sigma is proportional to tau is proportional to 1 by root T. From here we can say that sigma theoretically, that means conductivity theoretical value is proportional to 1 by root T. But experimentally we have got that sigma is proportional to 1 by T. There is a difference of root. So this prediction of CFET is not in agreement with the experimental observations. Now the third failure is dependence of electrical conductivity on electron concentration. According to classical theory, electrical conductivity sigma is given by sigma is equal to n e square tau by m. Here we can say that sigma is proportional to n because sigma is in the numerator, n is also in the numerator. So we can say that sigma is proportional to n. That means divalent and trivalent metals with larger concentration of electron should possess a higher electrical conductivity than monovalent metals, which is a contradiction to the fact, because experimentally it was found that the conductivity of monovalent metals like copper and silver is greater than that of divalent and trivalent metals like zinc and aluminium. From here we can say that more the n, more will be the conductivity. For zinc and aluminium, n is more. But when you compare with copper and silver, though n is 1, the conductivity of copper and silver is more than that of conductivity of zinc and aluminium experimentally. So this theory failed to explain the dependence of electrical conductivity on electron concentration. So these are the three failures which we have seen for the classical free electron theory. Thank you.